JavaScript for AllegroGraph. Take the stage.
Okay, thank you, Steve. So in the past, I've given several webinars. Let me see. About many things you see here in this architecture picture of AllegroGraph. Obviously talked about SPARQL, and in the near future we'll do about our SPARQL 1.1. I've given talks about a Prolog, about geospatial, social network analysis, etc., etc. But one thing that people have asked us for a long time now is to have a stored procedure language. And so as of, I think, 4.3, we provide JavaScript as our primary stored procedure language. And that's what this lecture is all going to be about. So why use AllegroGraph JavaScript? Well, I guess most of the people in the audience will be people very familiar with databases. And I mean, you can't even imagine writing a very serious database application if you can't at least write some stored procedures. So that's one reason why we needed one of those languages. The other thing is, with our JavaScript, we also make it very easy to write a stored procedure or some server-side script and then make that available through a REST call. So in many cases, you could make your database available as a SPARQL endpoint, but then one, you make it hard for developers to put SPARQL queries in their, say, in their web pages or in the application layer. Or you want to shield off the SPARQL endpoint and you just want to give them a regular, nice, neat API with the functions that you pre-wrote for the people that are going to use your database. So with what we have, we can make it very easy to turn your functions into REST calls. Then, so I guess most of the people in the audience will be familiar with SPARQL. And of course, we all know that SPARQL is not a programming language, but a query language or access language. Yeah, and of course, with SPARQL getting better and better all the time, you can do more and more. But there's still many places where SPARQL is just too cumbersome to write what you want to do. Yeah, just think of say a graph algorithm. Say you need a bidirectional search because you have a graph with a high branching factor, and if you want to find a path from A to B, then just doing depth first or breadth first will be just too expensive, and then bidirectional is better. Well, I mean, if you want to write something like that, you forget about it to do that in SPARQL. Sometimes you want to do data mining, and for example, in other webinars, I show our life sciences database and how I can find all the clinical trials that look like this clinical trial given a set of predicates. Well, again, you probably could write it in SPARQL, but it's easier to just write it in the programming language. Then what we do a lot is work with events in our triple store. And when you talk about events, then you regularly talk about temporal bounding boxes and geospatial bounding boxes. And in SPARQL, that usually tends to blow up in a lot of clauses that you need to use. Just easier if you can turn it into one programming call. And then finally, if you want to do some workflow, yes, say you have an application where you need to ask something from server 1 and then from server 2 or database 3, and then you need to ask something from the user and then combine all of that and do something intelligent with it. Again, you need something where you can do scripting. So that's another reason why you want to use JavaScript. And finally, with SPARQL 1.1, you now have magic properties where you basically can put whatever magic you want in the property and use it straight into your query language. So for example, we have one for Solar. We can now integrate with Solar. And here we say find all the things where as matches in the Solar server with these words, Medicaid, disaster, and Feingold, and then for each of them, find something else. And it would be nice if you guys could, or the users could write their own magic properties. And the same thing for Spin. We now support Spin, and in Spin, you need to define sometimes your own functions. And in the Spin standard, they propose JavaScript. Right now, we're not supporting it, but in the near future, we'll have a release where you can write all these magic properties and spin functions in JavaScript on the server side yourself. Yeah. So this is about the why of JavaScript. Then how to run it? Well, I'm going to show you that in a second, but it's fairly simple. You can write JavaScript, make sure it ends in .gs, and then put it in the scripts directory in AllegroGraph, and then you can just call it from wherever you want, as long as you use the X scripts to tell which scripts you want to use. Again, it's in our documentation, and getting to our JavaScript documentation is easy. Just go to Google and type France AllegroGraph JavaScript, and you get to this page that shows you the whole library that we built on top of our JavaScript compiler to work with the triple store. So, and again, take the time to go through this page. We describe how you can work with triples and parts of a triple. Yes, how you can take any string and turn it into a literal or a resource, but also how to work with our encoded parts. So in AllegroGraph, we not only support strings, but we also have a whole type system for integers, longs, floats, telephone numbers, dates, geospatial properties. And so we needed some glue code to make it easier for you to work with these encoded data structures. So, well, that's all in documentation. Then we implemented the main things that you do with the triple store. You can ask for the name, get all the triples with a combination of subjects, predicate, objects, and graph. You can get the results of get triples as an array back. You can delete triples, add a single triple. You can do your commits and rollbacks like you can do in any stored procedural language. You can run SPARQL and Prolog straight from JavaScript, and in my demo I'll show you that, but basically what happens, you embed SPARQL in your query, you get a cursor, and then you can run through your cursor, and you can even do text search straight from Java or talk to Solo straight from JavaScript, etc., etc. Then by providing JavaScript, we now also make it easier for people that want to use a triple store as a graph database. If you want to do graph algorithms in the client, then of course that's going to be extremely slow. But now with JavaScript, we make it very easy to be straight in the server where you then can do your graph algorithms. We did pre-program a few of those. If you're going to use JavaScript and you want to make any of our other methods that you can use in the client, then we'll just make sure that we'll do this for you in JavaScript too. Now one important part is that JavaScript, of course, has the map or the basic JavaScript hash table, but the JavaScript hash table is relatively slow when it has to work with our own internal parts of a triple. Yeah, because if you have triples, then well, when the human being looks at a triple, it sees the strings, but internally we have replaced all these parts with long numbers. And if you want to do millions and millions of operations in a hash table, then JavaScript hash tables are a little bit too slow. So we created our own server-side hash tables. We call them UPI hash tables. And then they will be very, very fast if you use this particular. And I'll give you a demo of how to use these hash tables. And then finally, and again, I'm going to show you this, but we describe in our documentation how you can take any function and turn it in basically one line into a REST call. And I think this is about all I wanted to show about the I mean, this is all I'm going to talk about. Now let's go to the second part of my talk, which will be all demonstration. Oh, I didn't want to show you this so much. Let me go here. So here we have the web interface to AllegroGraph. It's called AllegroGraph Web View, in this case for 4.4.0.1. And you can have scripts that you store. So you can, we have an editor here in the server-side scripting part, and you can write whatever JavaScript code. It's actually a smart editor, so it will even do parenthesis matching, and you can even store them and load them from your site script directory. But for this demo, I just put all the functions that I want to demonstrate in one big file. So here's all of the ones that I'm going to talk about. And then I have another one available here. So let's just for fun go to the overview. So here we have the database. So I haven't, it's already closed, so it has to open the database again. Take a few seconds. Okay, so now the database is available again. Yeah. So here is the main interface for the database. I can click on scripts, and then here I can type whatever I want to do. I can say for Andrew is 1 + 1, and I can run this. I get the result is 2. So let me now go to the main scripts. Let me do the first function in JavaScript. Yes, this has got nothing to do with the triple store yet. This is just to show how you can work with scripts and with JavaScript in the server. So here we have the function factorial, and then the next line is where we define the surface. So, well, actually, let me first run this. Just do this. Yeah, I say factorial 20. Yeah, if I run this, I get at the bottom the result of factorial 20. But this is the interesting line, because what I do here is I define a surface. So I say server defined surface. I'm using get or post, in this case get. And then in the API I will call the function factorial. And then when I use factorial, you use the anonymous function to apply factorial to the request parameter n. So basically, when the surface is factorial, it will go out to find the parameter n, we'll get the value, and apply factorial to it. Yeah, so let me show how this works. So I can basically do this call here. This is a long call. Factorial, where n is 20. Yeah, so this is the whole web call. Yeah, localhost repositories. I'm using it for the database politics. There will be a custom function with the function factorial where n is 20, and I run this, and I get the result in the browser. Yeah, so this is it. Still nothing to do with the triple store, but just how this works. And if I wanted to save this, let me go here. This function, I actually could save this, say, as factorial.js, and I would save it as a side script, and now it's saved. Yeah, and now I could use it again later if I go back here. Let me go back to the first script. So I defined the server in one call here. Usually when you want to do things a little bit more systematic and you want to do some error corrections, then what people do is they actually write a special surface for a function. So here, so what we usually do is you create what we call here the factorial surface given a particular request. Then we say n string is the request parameter n, and then if we find the string, then we parse the integer from there, and then we return factorial n. And then the way to define the surface is this simple call. Yeah. Now, oh, actually it's factorial again. So here's the shorthand version if you have just one parameter. If you want to do error checking and be a little bit more formal about it, then this is the way how to do it. Okay, so now let's go and talk to the database. So here is a function called SomeBasics. And let me make a copy, stick it here, and then we do SomeBasics. So we make an empty map, and then I want to show you various calls that you can do against the database. So instead of doing them one at a time, I just make a map, and then I just put the key as the thing I want to demo and what I do in a triple store. So here I say I want to find a name, and I'm calling store.name. I want to know what the size of the database, so I say store.size. I want to know what text indices I have available in the database, so I say store.text indices. I'm doing a search, so I say make the word happy, and then find in the search happy animal rights. Yeah. I want to know what the normal indices are in the database, and I store that here. There's a namespace, well, I guess you can call it a factory, an object. So I want to know when I use the abbreviation RDF what it actually stands for. So I say namespace.lookup_RDF. Then I can use with cursor, work with cursor. So I say store, which is the general variable that holds the store object, get triples, and then I say, well, I know there's a politician called Rick Larson, 00 with 000, so I get all the triples for this guy, and I store it in the cursor. Then I say, well, I have a cursor, so let's set the triple to cursor.next. So now I have one triple, and I put the triple in my map, and then I say, give me the subject is the triple subject and triple predicate, and then give me the map back. Yeah, so let's try that out. And so here you see the result. Yeah, so the name was politics short. There's so many triples, the name of the text index, etc., etc. Yeah, so note here is the whole triple, and then here is the subject and the predicate. Okay, are there already questions for me to answer? Okay, good. So let's go back to the main. So now let's do something more complicated. Say I wanted to find all the predicates for a particular class. Yeah. Now before I go there, let me go back to my Windows screen. Actually, let me go back to my Windows screen. And let me go back to here. So actually, I'm working with a database called Politics Short, which has information about politicians and information and newspaper articles where these politicians appeared in. So let me just find a particular person like Dianne Feinstein. So what you're seeing here, by the way, is our visual interface to the triple store called Graph. And so I find Dianne Feinstein. If I look at her, then we see what do we know about Dianne Feinstein. She's from California. This is all the committees she's on. And so all the subcommittees. So if I click on the subcommittee, I get that this committee has a parent called the Senate Committee on the Judiciary. I can click on that one and I get all the people on that committee and all the subcommittees. Let me go back. You see some more information like that she's Jewish, married, female, comes from San Francisco as a Democrat, and then a bunch of newspaper articles. I could click on one of those, and then you see that this newspaper article had 3 government people in it, some important concepts, some organizations, some other people, and some places, etc. Yeah, so this is roughly the contents of the triple store that I'm showing you. So let me go back here. So now I would like to find all the predicates for a particular class. Yeah. So, and of course I could write this in SPARQL. Yes. I mean, let's see if I have that available. Localhost. Let me look at the queries. In this database, look at the queries, saved. Yeah, so here would be the typical SPARQL query. Select distinct P where S is of RDF type person and an SPO, and we'll get all the distinct P's. But this time I want to write this as a JavaScript function. So I take this code here, I put it here, and so what happens here? I say find predicates for a particular class, and then the first thing I do is I make one of these special hash tables, UPI hash, and then I ask for all the triples where the predicate is RDF type and the object is the class, and then I apply for each to this cursor. And I apply the anonymous function that applies to every triple. And so for every triple, I take the subject. And then I look for each triple for that particular subject. And I set in this map as the key triple predicate and as the value true. And when I'm done, I return the keys of that particular map. So when I run this, okay, let me take this. So what you see here is 2 things. I define a surface. Let me first, I define a surface that I call get with the name find predicates. And then again, what you saw in Factorial, this is how you get the CLS parameter out of the API REST call. But just let's first do this in this thing here. So here you see all the predicates for the class person. And I can also do this as a surface. So I take the copy of this, copy it here, and here you see as a JSON object in the browser. So again, you can call this any programming language, and you get all the classes. Yeah, just as an illustration of how this works. Now this, I will give you this file later. See, I don't know why there's a P here. I will give you this file later. So here is a much neater way. So this was a kind of the JavaScript function where you use anonymous lambda. Some people prefer to do it this way, where you first make a table and then you, well, this is the slightly more elaborate way, but probably also more readable. And then let's do the same function, and let me illustrate how to use SPARQL in your JavaScript. Yeah, so here you have a function find predicates for class, predicates1, and then you say the cursor is stored at run SPARQL, and then you get the SPARQL query that I showed you earlier. Yeah. And then if you want to give this back to the user, you say list is empty list, and then for each row in the cursor, push the value to the list, and just for fun to show that you can do whatever you want to do with these strings. You uppercase the list, and then you return list. Yeah. So let me take this here, and I go here, and let me uncomp this guy here. So if I do this, so now you see the same things you saw before, but now I've turned them into uppercase. Yeah. But just as a simple demo of how you can mix SPARQL in the JavaScript. Actually, what I wanted to do but didn't get to it is actually show this in one JavaScript, run both Prolog and SPARQL, and then do something with the results. So here you see a simple example of, well, the same thing as in SPARQL. You can also run Prolog and return the results. And then some interesting, and then I'm almost done, something more having to do with graph analysis. Yeah, so if I go back to the original demo, sorry, let me go back to the database here. I go here, and I had Diane Feinstein here. So here's Diane Feinstein. I say I have John McCain here. And say I want to find the links between John McCain and Diane Feinstein. Then I can actually in the GUI click for, say, the committees that the person is on, the common committees or the current committee. And I say OK. And then I can ask the database, so how are these two people linked? And I get a lot of results back, and I can choose a few. Yeah. And so you see that they're never in the same one, but here you get the shortest path between Diane Feinstein and John McCain. Yeah. So now, what if you want to do the same stuff in the JavaScript interface? We go back to. Oh, here it is. Yeah. So what this function in Graph uses is a server function called bidirectional pass, where for the shortest path you actually begin at where you start both at the beginning, the start point of your search and the end point, and you work in rings toward each other. So let me take this code here. So this one here, and we go here. Yeah, so what you do is find past person 1, person 2, given a set of predicates and the maximum depth. And then what you do is the first thing you do is you create a generator. Basically, a generator is a function that tells you how you go from one node to the other, through a set of predicates. So the input to a generator is always one node, and the output is always a list of nodes. And then once you have the generator, you can call a function on it like bidirectional path, where you have a start point and an end point in the depth. Yeah, and the generator already knows about the predicates. So if I run this function, then you get the results here. Again, this, if you want to put this whole thing in a REST call, but I'll just leave that for now. And then the final one that I'm going to show is this function here. Let's see, why does my screen not move? Here. Yeah. So when you do social network analysis or graph functions on really large graphs, then doing this on the raw data structures in AllegroGraph is not always the most optimal way. So one of the things that we did is, for all our graph functions, we built an intermediate step where you can turn a group into an association list in memory. So it's like a very efficient data structure that will make your graph search 2 to 3 orders of magnitude faster. So I'm showing that here. So here you first, and you're going to see this stuff later when we send you the file. Yeah, but this is a function to get the distinct objects out of a cursor, and then we make a function government people, where we say there's a cursor for give me all the triples where the predicate has government person, and then give me all the distinct objects out of this cursor. So now we get a group of people, all the people in this database, and then I can assign various strings to this particular function. So just for fun here, I say government people as a string is related to government people here, or honest people is related to government people. And then in the surface, I get the person 1 and the person 2, the guys that I want to find a link between. Here is how you split the predicates up in separate predicates. Then you get the depth, and then you choose the function that you want to apply here. And then finally you say return find paths as matrix between the person 1 and 2 given a group of predicates, depth, and function. Where here we do the magic that I talked about to make the special data structure. So again, you make a new generator based on a set of predicates, and then you say apply the new generator is the same generator we have here, but now it's a matrix. So now you created this extra this new smart data structure, and then finally you call the shortest path on this. So let me show how this works. And then you, of course, define the service again. So let me run this. And then, oh, I never know how to get to the end. And I can run this here. And I get the shortest path using this intermediate data structure. Okay, and this is almost the end of the demo. We have some other functions that we built in for you, and you can study it. We actually can run, use AllegroGraph as a server for Ajax. Again, I don't have the time, but you can emit HTML code, so you can have AllegroGraph also work as your web server or as your the support for Ajax. And in the file, you will find some geospatial functions that we wrote just to show, for example, find all the cities near a particular city. But again, it's now half an hour, so let me go to the questions. Okay, so one question is, why did you choose JavaScript? You mean JavaScript as a language? Well, we wanted the language that most people in the world are familiar with, and it seemed to be JavaScript. I mean, almost almost anyone that now can build a web page knows how to write JavaScript. So we already, of course, have Lisp as a language, but most people don't want to use that. We can use Prolog as a server side, but again, some people are afraid of that, but no one is afraid of JavaScript. Okay, another question is, tell us about MongoScript. MongoGraph. Yeah, oh, that's another. I gave recently a webinar how we can also, in our Triple Store, manipulate JSON objects, and we actually can store JSON objects as triples and retrieve them as triples. So we can do 80% of the MongoGraph API. Yeah, so if you are a JavaScript programmer and you need to store JavaScript objects or JSON objects, and you want to do complicated join queries on your objects, you actually could use AllegroGraph just straight for doing some more advanced stuff with JSON objects. Oh, another question: when will 4.5 be out? I guess isn't that? Yeah, I think next week, the end of this week or early next week, we will have 4.5 coming out. We had 4.4, which now has the SPARQL 1.1. In 4.5, one of the new things that we have integrated with Solar, a whole lot of bug fixes. But the most important thing is we now integrate the Solar. Oh, what's the difference between a user script and a site script? Well, I have an expert with me. Andrew, what is the difference?
I think user scripts only work for database users, and site scripts work for everybody.
Oh, yeah, sorry, yeah, you're right. So site scripts are globally available. So, so if you store, so we have, in our database, we can define users. So let me go back to here, so we have users, yeah, so you can add users to the system. And if you have user scripts, you can make, users can add their own scripts, but they won't be available to anyone else. But if you make a site script, they will be available to all the other people in the system, if you have the permission to use arbitrary code. What did you mean when you said we will send the file out? Okay, yeah, so the file that I'm showing you here, after we release 4.5, we'll also make this file available on our website, so you can run all the JavaScript that I showed here. 90% of what you see in this file runs in 4.4. There's a few thingies that require 4.5. Yeah, so we'll make it available after 4.5 is out. Is the politics small database also available? Yeah, just send me an email. I can send you the triples. It might actually be, yes. Anyway, I'll just send it. We'll post it. Oh, sorry. Yeah, I just heard that we're going to post it. Yeah, so when we make the JavaScript file available, we'll also make the data available. So can you actually register a user script as a REST service? That's a good question. Can we take a user script and make it available as a REST?
I believe so. I think it is only available to that user.
Oh yeah, but it will only be available to that user. Well, we could test this fairly simply. So we could say AllegroGraph. Okay, well let's not. No, let's not go there. We're done with it. Okay. Yeah, let's not go there. Okay, so guys, let me go back to my presentation here, the PowerPoint. So, as I said before, after 4.5, we'll make it available. We have some users already playing with JavaScript, working with JavaScript. Please just try it out and just let us know if you find things missing or if you want us to write any additional code in the library, because we'll be happy to make that available to you. And keep adding that to the database. And with that, I would like to conclude. Thank you very much for your time.